Hi campers, it's time to play with the data you collected for your survey. So let me share the Excel sheet I have, and of course this is on the on Blackboard, and you should be able to see my mouse here. So I had to clean it up a little bit because sometimes people would write the word minutes in a cell. I think that was the only thing, or they didn't put a code, they put words like most, very likely, unlikely, something like that. So I cleaned all that up. And as you can see, we have across the top here, you'll see I put little keywords for the questions, and you'll have to refer back to the survey to see what the actual questions were. Now this first column was the survey numbers. You each had about 1 through 5. They're all out of order simply because I've changed this. I've organized it such this last column here that is gender, I've sorted it so that all the ones are together, which would be row 2 through 36. You see this is the last row of data from a 1, which is male. And then rows 37 down almost to the bottom are 2s. That means that's data from the females. And then there's 2 people at the end that do not identify as male or female. So this will allow us to do a couple of different things. But now that we have all this data, what we want to do is run some stats, ask some questions, and see what the answers are. So we have 2 kinds we can easily do. One would be a correlation coefficient, the other would be a t-test. Let's start with correlations. Now for that you have to have at least 2, and we're only going to do 2, variables that you think might be related in some way. And they have to be continuous variables. So that means they actually can be a range of values from low to high. So something like how many minutes do you exercise in a week? I think it's minutes. We have to check the survey. Or in a day, maybe it's minutes a day. How many times do you do something related to religious practice in a day? It could be 0 up to whatever. I think there's a high of 30 in here. How many drinks do you have? It could be 0 up to whatever. We have a high, it looks like a 56. Hopefully that's in a week. Yikes. So that's a continuous variable. You can choose any 2 continuous variables to run a correlation. So what I'd like you to do in your assignment, you're going to be asked to hypothesize about a relationship. So it could be, you know, your GPA, which is a continuous variable, and the number of hours a week you study, or minutes, however we did that. This is hours watch. Oh my goodness, of TV. Let's see, that's question 11. And I actually have to look that one up. Because I wonder now, on this one, there's somebody put 200 hours. I'm wondering if that's even possible. Because question 11 asked, during the semester, how many hours on a week, on average, do you spend watching movies or TV shows? And somebody put 200. That's an awful lot. Now, as a researcher, I can't just say, well, that's impossible, I'm going to throw that out. Somebody might actually do that. So we're going to leave it. That's what we would call an outlier. So I want you to pick any 2 continuous variables and run a correlation coefficient. To do that, just find any blank cell. So see my mouse right here. I'm going to just click on an empty cell. Now I'm going to go up here where it says formulas on the toolbar at the top. See my mouse, formulas. Now over here it says insert function. So I'm going to click that. It's going to bring up this box. Now this will have a whole list of tests. Because I've already been doing these, Corel for correlation and t-test are at the top. You may have to scroll down to find those, but I'm going to say I want to do a correlation. So I hit OK. And it's going to ask me what 2 variables. And now an array is just a list of data. So I'm going to pick the 2 columns I want. The first one's going to be array 1, the second array 2. So let me do, let's do alcoholic drinks versus, let me see. How about with overall mood? Now I can hypothesize either that more alcohol will increase your mood, or maybe I think the more alcohol you drink, the less happy you are, and there's a negative correlation. For your assignment, I do want you to pick some variables and then hypothesize what direction do you think the correlation would be. Would they move together, like the happier you are, the more you drink? Or would they move separately, like the less happy you are, the more you drink? You just pick something with whatever logic you want, and then go ahead and run the correlation. So I'm going to do mood. So it doesn't matter which is array 1, array 2, but I've got mood here. So what I have to do is click on mood, and I have to, I'm holding the mouse button down. I don't know how to, I'm left clicking the mouse to get all of the data from that column. Now I have highlighted the whole column and I say okay. What I didn't do, oh, it's giving me a little trouble here. It should just start over because it's giving me grief for some reason. What I didn't do is just highlight the column from the top and like this, because that includes the first cell from row 1, and that's my title. And there's a way to get around that, but I just don't want to deal with it right now. So let me just kind of delete this for a minute and start over. Okay, I have my clean cell. I say insert function. I'm going to do a correlation. For array 1, I'm going to do overall mood. So I highlight all the data from that column. Okay, now I'm going to click into array 2. And what was I going to do? Number of drinks. So alcohol, here it is, column N. I'm going to just highlight that whole column to get my second array. That's going to compare the numbers in each column. Now I just go okay. And here back up in my empty cell is the correlation coefficient, which is 0.07. Now you should remember that means pretty much nothing's going on. These two variables are not related in our data set. And it seems to be no predictable relationship between the number of drinks you have and your overall mood. Now mood is a continuous variable because we assume you can kind of be anywhere from unhappy to happy. But we only have 5 possible points you could have picked. So it might be sort of a restriction of range issue. We're not really sure. But anyway, in our data, nothing's coming out from that. Let's do something that might be a little bit more obvious. Let's do like hours that you study and GPA. So let's see, I have to look up, I'm just looking at the survey to see which questions those are. Let's see, it's, okay, number 7 is hours studying. And then GPA is 23. So I want to do column 7 versus 23. Let me just double check my numbers. Yes, 7 and 23. So I'll try it again. I'll just pick an empty cell. I'll say insert function. I'll select correlation. And then it wants my data. So I need to find, let's see, that's not the one. 23 and 7. Okay, hours study here. All right, so here's my first column, hours of study a week. Okay, I got that. Now I put my mouse into array 2 and I go find question 23, which is GPA. Here it is over here in column X. So I select all those cells in column X. Okay, I hit okay. Boom, where's my correlation coefficient? I got to go to my cell. Here it is, 0.15. Well, it's in the direction I expected. It's positive as hours studying, GPA goes up, but 0.15, pretty weak, not a huge lot going on there. Now in hindsight, here's the thing with correlations. In science, we make our prediction up front. Oh, I think those who study, they're conscientious, whatever, for whatever reason, they're studying more, they learn more, they're going to do well. Well, in hindsight, I go, oh, it's not much is going on. What if this had actually turned out negative, like negative 0.15? In hindsight, it would be easy to go back and say, oh, well, of course, the people who are struggling and really not doing well, they're the ones that need to study more. And of course, it would be a negative correlation. Now, that's the kind of thing, no matter what happens, after you've crunched the numbers and you have your results, it's easy to make up stories to explain it. And that's why in science, we have to actually make a prediction at the front end and then see if the data are consistent. I know it seems really strange, but I hope this is a good example where you could come up with reasons after the fact for any result you get. And that's not science. Okay. All right, so that's how you do correlations. Now, real quick, let's see if we can do a t-test. A t-test is when you have two groups, so let's say males and females, and you want to compare them. So I already have my data split up, and I know here that row 2 through 36 are all ones, that's all males. And then 37, almost to the bottom, is the females. So to do a t-test, I find an empty cell right here. I say insert function, again in the left-hand corner, see my mouse, click there, and I pick t-test. And I say, okay. Now it's going to want my two groups of numbers that I'm comparing, and then a couple other pieces of information. So let's start out with array 1. Let's see if I want to, let's do texting and driving, males versus females. I have to say there's not a lot in our survey where I really expect a gender difference, but well, how about, hey, let's do meet professor. Are males or females more likely to meet with professor? So here's the data for males. See under column T, that's the meet professor question. I'll select rows 2 through 36 to get the male data. Let's see, that's to 36. Okay, so there's my male data. Now my female data, array 2, I have to get, what column was it? Column T. I have to go from row 37 on column T all the way down and just skip the last two people because they don't identify as male or female. Okay, so they're my two columns of data. See here in the box, T2 through T36 was the data for males, and it's going to compare that to the data from row 37 to 94 of the same variable, and because that's the female data. Now it says tails. For this, we're just going to say two tails that you'll learn in stats, but it's a little more conservative. And then type of test. Now look down here, it describes the test types you could have. If I put in a 1, that means that in my two groups, there's actually a connection between each data point. Like this would be if I had people do a pretest and a post-test. So that in both of the group scores that I'm comparing, there's a data point from the same person. Like participant A had a pretest and a post-test. Participant B had a pretest and a post-test. So the data are paired between the groups. We don't have that because we have different people in each group. I got males here and females here. And so the data are not paired in any way. So because it's two samples or unpaired, it says to put in a 2. And then this other thing about variance, just ignore that. So if you're going to compare males and females for anything and use a t-test, here we're going to have two tails and type 2. Now I just click OK. Okay. Now I go back to the cell that I was in. Here it is. The number here now, it's not a correlation coefficient. This is a t-test. It's my p-value. Now what kind of p-value do I have to have before I say there's a significant difference? Something less than 0.05. Well, this is not less than 0.05. 0.12 is greater than 0.05. So it's telling me there's no significant difference in males and females and how much they report meeting with their professor. So you could try a t-test. Again, I'm not sure if there's anything in here that lends itself to us thinking it's going to be different, but you can certainly investigate some things. You can run a correlation or two and review the video if you want to see how to do that. And I'll also post some written instructions, but again, it might be easier to watch. So with those tools, you should be able to complete the assignment on data and have some fun checking out some ideas you have. All right, thanks guys, and that's the end of this video.